Welcome to qnawire.
In this problem on the topic of analysis of structures, we are given the portion of a truss shown in the diagram that represents the upper part of a power transmission line tower. Now we are given a loading and asked to determine the force in each of the members in the truss located above point AHJ, and we want to state if either member or each member is in tension or compression. Now, for the free body diagram of joint A, which we have as follows in the diagram, we can see that FAB over 2.29, using some geometry, is equal to FAC over 2.29, and this is equal to 1.2 kilonewtons over 1.2. So immediately we can find the force on each of the members FAB and FAC. So we get FAB to be 2.29 kilonewtons, and this is tension. FAC is 2.29 kilonewtons, and this is compression. So we found the force for the first two members. Now we'll look at the free body diagram of joint F. So we're looking at the first free body diagram that we've drawn here. So for joint F, we have the force FDF over 2.29 is equal to FEF over 2.29, and this is 1.2 kilonewtons over 1.2. So we can immediately find the force of the two members FDF, which is 2.29 kilonewtons, and this is a tensile force, and FEF is equal to 2.29 kilonewtons, which is a compressive force. So from that free body diagram, we found two more of the members' forces. Next, we're going to joint D. So we've drawn the free body diagram for joint D as above. Now, using this free body diagram, we have that the force FBD over 2.21 is the same as force DE over 0.6, and this is equal to 2.29 kilonewtons over 2.29. So we can see that FBD is equal to 2.21 kilonewtons, and this is a tensile force. FDE is simply 0.6 kilonewtons, and this is a compressive force. So from joint D, we found two more of the forces. Now we move on to joint B, which in our diagram, in our free body diagram, looks as follows. Now, in joint B, if we take the right direction to be positive, and we take the sum of all the x component of the forces, this must equal to 0 for equilibrium. And this gives us 4 over 5 FBE plus 2.21 kilonewtons minus 2.21 over 2.29 into 2.29 kilonewtons, and this must equal to 0. So from here we can see that FBE must equal to 0. Now, still on this free body diagram, if we take now the upward direction to be positive and look at the y components of all the forces, again, the sum of these components must be 0. There is no net motion in the y direction. And this is minus FBC minus 3 over 5 times FBE, which is 0, minus 0.6 over 2.29 into 2.29 kilonewtons is equal to 0, which means that we can find FBC, and we get FBC to be negative 0.6 kilonewtons, or 0.6 kilonewtons, and this is a compressive force. Now we move on to the free body diagram for joint C. So we've drawn the free body diagram for joint C as circled here. Now, from this free body diagram, we can calculate the forces required as follows. Again, if we take the right direction as positive and we take the sum of all the forces along the x direction, this again must be 0. So that's FCE plus 2.21 over 2.29 into 2.29 kilonewtons. This must equal to 0. So we can find FCE from here. We get a negative answer for FCE, which means it is compressive, and that's 2.21 kilonewtons, which is compression. So we found another force for another member. Using the same free body diagram, we'll now look at the vertical components, taking again upward direction to be positive. The sum of the y components of the forces must again equal to 0 for equilibrium. So minus FCH minus 0.6 kilonewtons minus 0.6 over 2.29 into 2.29 kilonewtons is equal to 0. So again, we find FCH, and we find this again to be negative. So we get FCH is equal to 1.2 kilonewtons, and this is a compressive force. Now, lastly, we look at the free body diagram for joint E. So that's the last one we've drawn above. So joint E is as we have in the diagram, and if we calculate our forces from this free body diagram, we can do the same as we done before, taking the right as positive and taking horizontal components. Sigma of Fx again must be 0, which means that 2.21 kilonewtons minus 2.21 over 2.29 into 2.29 kilonewtons minus 4 over 5 times FEH is equal to 0. So from here, we find that FEH is equal to 0. So we found another member force. Now, lastly, we can take upward as positive and again take the sum of the forces in the y direction. And again, this must equal to 0. So this is minus Fej minus 0.6 kilonewtons minus 0.6 over 2.29 into 2.29 kilonewtons minus 0 is equal to 0, which means again we can solve for this force Fej, and we once again get a negative answer. So Fej is 1.2 kilonewtons, and this is a compressive force.